Hello everyone, I'm going to discuss HCl and miscellaneous inorganic compounds. This topic is obviously about hydrochloric acid, so I'm going to discuss its history, the uses and sources of HCl and its process. Also, the miscellaneous inorganic compounds such as bromine, iodine, fluorine and fluorocarbons, fluorosilicates or silicofluorides, alumina, aluminum sulfate and alums, aluminum chloride, copper salts, molybdenum compounds, barium salts, strontium salts, lithium salts, boron compounds, sodium dichromate and hydrogen peroxide. So let's now proceed to the first part of this lecture, which is the history of hydrochloric acid. So in the 15th century, hydrogen chloride was discovered by Basilius Valentinus. The commercial production of hydrochloric acid began in England when legislation was passed prohibiting the indiscriminate discharge of hydrogen chloride into the atmosphere. This legislation forced manufacturers to use the Leblanc process for soda ash to absorb the waste hydrogen chloride in water. Hydrochloric acid is a colorless and odorless inorganic chemical system with the formula of HCl. Aqueous solutions of HCl are known as hydrochloric acid, while if it is in a commercial grade, it is called muriatic acid. Here are the users of hydrochloric acid. Almost half of it is for metal industry, followed by chemical and pharmaceutical manufacturing with 33%, and then miscellaneous uses and food processing. Lastly is oil well oxidizing. Uses of hydrochloric acid is to manufacture glue, to purify common salt, for bleaching in textile industry, and in preparation of glucose and chlorides. Sources of hydrochloric acid. One is byproduct in the chlorination of both aromatic and aliphatic hydrocarbons. So these steps is in the production of byproduct acid include the removal of any unchlorinated hydrocarbon followed by the absorption of HCl in water. This operation furnishes nearly 90% of the acid. Number 2. Salts and sulfuric acid reaction. 2 moles of sodium chloride is reacted with sulfuric acid to produce sodium biphosphate and 2HCl. The reactions of salt-sulfuric acid process are endothermic. Sodium chloride can be obtained from seawater, salt lake, and subsoil water, while sulfuric acid can be obtained by contact process. In the manufacturing of hydrochloric acid from salt and sulfuric acid, salt and sulfuric acid are introduced into the reactor. Sodium sulfate is removed while the other product continue in a cooler. The unreacted is washed by water and is separated. The remaining product containing HCl vapor is passed through an absorber. And then the vapor are absorbed that turn into liquid HCl. The remaining gases are passed through the scrubber. The gases will be released if any are removed by water, and it also can be recycled. Number 3. Combustion of hydrogen and chlorine. Simple reaction takes place as 1 mole of hydrogen and 1 mole of chlorine reacts to produce 2 moles of HCl. Both hydrogen and chlorine can be obtained during electrolysis of brine for manufacturing of NaOH. In the manufacturing of hydrochloric acid from hydrogen and chlorine combustion, the hydrogen is burning in combustion chamber in presence of a chlorine gas. The product was produced containing hydrochloric vapors. This vapor passed through this cooling coil, then the vapor are condensed through a liquid pump. A cold water is introduced from the outer side of the tube in a shower form, and the acid to dissolve vapor of hydrochloric acid, which is resulted to the production of liquid hydrochloric acid. The exhaust gas are released through the exhaust fan. Number 4 is the Hargreaves type operations. Here is the sample production of hydrochloric acid. In the flow sheet for hydrochloric acid, the most important of the salt furnaces in operation is the Mannheim furnace. This consists of a cast iron muffle composed of a dish-shaped top and bottom bolted together and equipped with blows to agitate the reaction mixture. Sulfuric acid and salt are continuously mixed and heated in a rotary furnace. HCl with some droplets of sulfuric acid and particles of salt will be cooled externally by water by passing through a series of S-shaped carbate coolers. The required product will be absorbed by the absorber in water in a tantalum or carbate absorber. The strong acid and weak acid are separated from the product in a separate storage, which is used in the stripper to recover the required HCl gas. Bromine is a heavy dark brown liquid which was discovered by Ballard at 1865. It is a member of the halogen family. For the uses of bromine, it is mostly used as flame retardants, which has 44%, followed by drilling fluids, and then biocides, water treatment, lastly is bromomethane. The process of bromine includes the oxidation with fluorine, which will be blown with air to free bromine, and the bromine is reacted with sulfur dioxide and absorbed. Here is the flow sheet from bromine from seawater. Iodine is a non-metallic element forming black crystal in violet vapor, which was obtained by Cortius in 1811. For its uses, it can be a catalyst for the chlorination of organic compounds and in analytical chemistry for the determination of so-called iodine numbers of oil. It is also for medicinal, photographic, and pharmaceutical purposes that is usually in the form of alkali iodides. Iodine was also made by reduction with sodium thiosulfate and sulfuric acid, and by the reaction of sodium bisulfate, either prepared at the plant by reacting soda ash with sulfur dioxide or imported. Fluorine is a pale yellow-greenish gas of the halogen family. It is the most reactive non-metal element and was isolated by Moissan in 1886. For the uses of fluorine, it can be for pharmaceutical products, toothpaste, anesthetics, Teflon, rubber, processing nuclear fuel, and positron emission tomography. Fluorine gas is generated by electrolysis under varying conditions of temperature and electrolyte composition. These variables often require cells constructed of different materials. Fluorosilicates or silicofluorides. It reacts with water to generate hydrofluoric acid and silicate acid. It poses similar hazard problems to hydrofluoric acid. For the fluorosilicic acid production, phosphorite turns into toxic gaseous mixture by wet process, and then it undergoes into water absorption that results into fluorosilicic acid, and then the recycling of distillation. Uses of silicofluorides. It can be used as insecticides, laundry sour, protecting agents, and fluxing and opacifying agents. Alumina is a white or nearly colorless crystalline substance. Bayer, an Austrian chemist, invented a cheap and feasible alumina or aluminum oxide production method in 1889. Figure 7 shows the essential steps in the production of alumina from bauxite by the Bayer process. Other processes for producing alumina are Mexican process, which uses alunite, a hydrosulfate of aluminum and potassium. Number 2 is French Pechiney, Number 3 is treatment of clays with nitric acid and continuous electrolysis of aluminum chloride. Aluminum sulfate and alums is an aluminum salt with immune adjuvant activity. This agent absorbs and precipitates protein antigens in solution. Alums can be used as water treatment, dyeing, as a mask, astringent, antiseptic for the skin, and to produce the aluminum hydroxide flock. Here is the manufacture of aluminum sulfate by the Door procedure. The mixture from the reactors is sent through a series of thickeners, which is operated countercurrently, and removed undissolved matter and thoroughly washed the waste so that when discarded, it will contain practically no alum, or bauxite, or shales, alunite, and clay. Aluminum chloride. This salt was first prepared in 1825 by H. C. Ørsted. It is a white solid when pure and formed by the reaction of aluminum and chlorine solutions. The uses of aluminum chloride is for petroleum industry, organic technology, and a catalyst in alkylation of paraffins and aromatic hydrocarbons by olefins. There are three methods in preparing anhydrous aluminum chloride. First is direct reaction of liquid or gaseous chlorine with metallic aluminum. Second is the simultaneous reduction by carbon and chlorination by gaseous chlorine of alumina-bearing materials. And lastly is the action of hydrogen chloride on alumina. Copper salt, which is commonly known as blue vitriol, are prepared by the action of sulfuric acid on a cupric oxide or sulfide ores. The uses of copper salt can be fungicide, algicide, root killer, and herbicide. Molybdenum compounds is a silvery white metal that is ductile and highly resistant to corrosion. Molybdenite is a mineral raw material. Compounds used to produce better adherence of enamels are molybdenum trioxide, ammonium molybdates, sodium molybdates, calcium molybdates, barium molybdates, and lead molybdates. It can be used as lubricant, corrosion inhibitor, a catalyst, dyes and pigments, and as fertilizers. Barium salts. The most common naturally occurring barium compounds are the mineral carbonate or witherite and sulfate or barite. The uses of barium sulfate are oil drilling muds, white pigments, filler, contour, photographs, paint industry, medicine, and adhesive. The process for barium sulfate are first is high temperature reduction, followed by chemical treatment and purification by precipitation. On the other hand, for the uses of barium carbonate, it can be for neutralizing agent for sulfuric acid, glass industry, synthetic dye stuff industry, brick and clay producers, flux for ceramics, PV tubes. Process for barium carbonate. First is acid treatment, followed by filtration and crystallization. Strontium salts is a salt of strontium and chloride, typically salt forming neutral aqueous solutions. It can be used as a red flame pyrotechnic compositions, tracer bullets, military signal flares, and ceramic permanent magnets. Lithium salts can be used as lithium hydroxide, which is the electrolyte component in alkaline storage batteries. It is also for lithium bromide, which is an air conditioning and the humidification of brine. Lithium salts are primarily used as psychiatric medication. It is primarily used to treat bipolar disorder and treat major depressive disorder. Its main sources are brines and ores. Boron compounds. The important naturally occurring ores of boron have been colemanite, tincal, and boracite. The most important compound for industrial use is borax. It is widely used as a flux in manufacturing of Pyrex glass and in making of glaze in enamells. Sodium dichromate is an orange to red colored, which is an organic compound that emits toxic chromium fumes upon heating. It is highly corrosive and it is a strong oxidizing agent. For its uses, it aids in corrosion resistance, helps clean metal surfaces, promotes paint adhesion, and use as an oxidizing agent in manufacturing of synthetic organic chemicals. Figure 10 is about the flowchart for sodium dichromate for chromate ore. The starting material for the manufacture of sodium dichromate and other chromium compounds is chromite. Hydrogen peroxide. It is most widely used peroxide compound, which covalent peroxide compound. Here is the manufacturing process of hydrogen peroxide. These are the local manufacturers of HCl and inorganic compounds.